Good morning, everybody. Thank you to everybody able to join us today, especially those joining us live. I know this is a hectic time of year. So we have a great program planned out for you today. We're going to learn about egg breaking and liquid egg products. So before we get started, some housekeeping. If you're joining on Zoom, there's a chat is turned off, but you can ask us questions on the Q&A feature at the bottom, and you can ask us anytime, and we'll try to get to as many as we can today as we go through our field trip. And if you're joining us on YouTube, the chat is turned off, so you can just sit back and enjoy the program. So first, I want to thank our sponsors for today's program, OPA, Ohio Poultry Association, Cooper Farms, and Grow Next Gen. So there is so much that goes into egg production and poultry farming, and so I wanted to make sure we'll cover as much as we can today, but we have also done 5 other virtual field trips. And you can find those on grownextgen.org/events/chickenology. And so some of those like happy homes, hens, sustainable egg production, turkey's best life, that sort of thing. And so as we get started today, Ohio is actually a really large egg producing state, which many people don't know. We're the top 2 egg producers in the nation with over 10 billion eggs produced each year. And agriculture is Ohio's largest industry, with 50% of Ohio's land in agriculture production, like egg and soybeans. So my name is Jenna Gregorich. I work for Ohio Poultry Association, and OPA, we work with Ohio's egg, chicken, and turkey farmers. And today we're going to learn about eggs and how they're processed and get to a store near you. So with OPA, I'm the bird health programs manager. So I work with farmers such as Cooper Farms, to help monitor for certain diseases and help with their biosecurity to make sure that their birds are staying healthy in order to get those nutritious eggs, chicken, and turkey products to a store near you. So as we get started, we've got some great guests here hosting us today. First, we have Lisa Kalig. She is the grower relations at Cooper Farms, and Cliff Wendell with the egg processing manager. So I'm going to hand it over to you, Lisa, first, if you wouldn't mind giving us a quick history on Cooper Farms and what all Cooper Farms does.
Good morning, everybody. Thanks so much for joining us. We're super excited to have you here at our liquid egg processing plant. So I just wanted to tell you a little bit about Cooper Farms before we got started. I think you're probably seeing a picture of Virgil and Virginia Cooper here in a second, and they are actually the founders of Cooper Farms. They started Cooper Farms in 1938. And it actually started with just a backyard flock of turkeys. And then in 1978, they added the chicken division with laying hens. And then in 1994, they added the hog division, and we now raise pigs as well. So they have 3 kids. They have Jim, Gary, and Diane. And actually, Jim, Gary, and Diane are running the company now. It is a family-owned company, and they are very involved throughout the week. Anytime, given day, you'll see them out and about, touring the different areas, talking with the team members, working with them. So we've grown from a small backyard flock of turkeys in 1938 to where we are now, which is over 2,000 team members. And we also raise around 7 million turkeys a year. We raise 950,000 hogs a year, and we raise 155 million dozen table eggs a year. So that's just a little bit about Cooper Farms. Just wanted to kind of tell you a little bit about the family and the history. And from that, we're going to go ahead and kick it over to Cliff, and he's going to talk about the liquid egg plant, and he is going to take you on a tour.
Thank you, Lisa.
Buddy. Welcome to be with you. My name's Cliff Wendell. I am the egg processing manager for Cooper Farms. I've been with Cooper Farms for about 8 years. My first position with the company was the plant manager of this facility. So we're going to get you out and we're going to show you what all goes on in this facility. It was modified in 2013 into a breaking facility. The facility has actually been around for roughly 40 years and started out as an egg packaging facility. Eventually evolved into a shell egg grading facility where we were selling shell eggs, not we, but another company at the time was selling shell eggs in cartons to retail customers. And then in 2013, the facility was purchased and was modified into a liquid egg breaking facility. And in 2014, in December, Cooper Farms and Weaver Brothers acquired the facility. And for roughly 5 years, we're just breaking liquid egg and selling raw eggs out in bulk tanker form. Those eggs were sent to other customers that would further process the egg and sell it out into mainly the industrial baking business. Then in 2019, they decided to make the investment to add the further process equipment. So we kind of evolved from selling bulk tanker loads to selling pasteurized liquid product down into 20-pound bag quantities, with most of our product essentially going into industrial food manufacturing businesses. Everything from ice cream manufacturing to dessert manufacturing to pasta manufacturing are some of our biggest customers. You can also see some of our products on the retail shelf. So if you go into a Kroger or a Walmart or something like that, and you're in the egg section, you can find egg bites, which is actually a product that one of our customers makes right now. You can find maybe egg whites in the milk cartons or even egg beaters in milk cartons. So that's a little bit of what product comes out of this facility. So we're going to head out on the floor and we're going to take you from the beginning of the process through the entire process to right before when the product goes out the door.
Great. Thank you, Cliff. I have a quick question for you as you're walking there. We get started with our tour. So when you said shell eggs, can you explain a little bit more what you mean by what's considered a shell egg and what those would be used for?
So you're going to see here at the beginning of our process where the shell egg comes into. And once the shell egg comes off the farm, it's got a couple options. It can go into a retail carton into the store, just like your normal person would go in and buy a dozen eggs or 18 eggs. Or it can come into the liquid processing facility where we can extract the liquid out of the shell egg and process it into further liquid egg for the industrial food manufacturing business. So right here is where the eggs are coming in. This is our nest run cooler, and we can hold about 6,000 cases of eggs in this cooler at any given time. Now in one day's production run, we can break up to 5,000 cases of eggs. So we essentially have enough cooler space for only about a little over a day's run. So the eggs are cycling through this cooler rather quickly. In most cases, the eggs don't get more than about 3 to 4 days old before they go through our process and are eventually pasteurized and shipped out the door. So when the eggs come in, as you can see right here, they're all identified with what we call a farm run ticket. It identifies exactly where it came from, the farm that it came from, the case weight, the date of lay, which is a lot of relevant information that we need to have traceability for all of our products. So once we get that, it's identified, we then weigh it on our scales over here, and it's identified into our system where we take that relevant information to track it through the process.
Cliff, I have a quick question for you. Can you define, what does nest run eggs mean?
So nest run eggs are ungraded, unwashed eggs coming straight from the farm.
Okay, and at this facility, there are no birds at that site, correct?
That's correct. We're considered an offline facility with no birds attached to us. Many of these larger complexes around the state and even country have what's called inline facilities where the eggs feed right into the production process. Essentially, no eggs are handled and they're conveyed right into the egg breaker or egg grater, wherever they're going. So you can see the cardboard. So everything's identified in our system now, so we know where it is and we can track it through our system. So once I get through and stage in the cooler, the next step of the process to come out on onto our production floor. And we'll head out there here just right now.
And Cliff, as you're walking there, can you explain a little bit about how the eggs, when they're laid at the farm, and then how they have to be put in a cooler, and a little bit more on that process? Because I know as we go into the processing room, we have this warming area. Would you mind talking a little bit about the temperatures and how that's monitored?
Yeah, there's a lot of regulatory standards that we have to follow throughout the process. And one of the first standards are the eggs have to be cooled down to 45 degrees within 24 hours day delay. So once they come off the farms, all of our farms have coolers to pack the eggs into. And those coolers are set below 45 degrees and ultimately stored there until our internal truck drivers are picking them up and bringing them into our processing plants. When they come in our processing plants, our coolers are monitored daily to make sure that they're staying under the desired temperatures, which in this case is 45 degrees. Now, from a regulatory perspective, we have 48 hours that we can take them out of tempering under 45 into our breaking process. But because of our limited storage, typically they're coming out of our cooler and they're going onto our machine within a day, day and a half at the most. So when they come out on the floor, they're staged in what we call the warming area, and they're prepped for the production process. So the people on our machine are then going to be bringing the eggs up to the line before they go on. They're going to pull the cardboard off and they're going to scan the cardboard, which will help track where the product is at all times. So we know what's going on our machine now. We know what storage container the liquid's going into, which we'll see here in a little bit. So we can identify where these eggs are at all time in case there was ever an issue from a recall standpoint or anything like that.
And Cliff, I have a quick question. So we have a from Miss Sarika. Are all the eggs that you get into this site, are they from Ohio farms?
We have a couple Indiana farms in our network, but yes, the high majority of them are from Ohio farms.
Okay, great.
So you're getting a good taste of the loading process right now. We do have some manual lifting that has to put the stacks up on the conveyors, but after the stacks get up on the conveyors, it's pretty much an automated process throughout the rest of the system.
How long does the whole processing cycle take from when the eggs are laid to go through and turn into the bulk tankers when they leave?
So when the eggs come in, they could be anywhere from 1 day to maybe up to 4 or 5 days, from depending on how large the farm is we're pulling from. They typically go on the breaking machine and go in our storage containers within a day of arriving here, and typically would be processed and pasteurized and shipped out within a week.
Okay, so pretty quick. So I see you have a lot of eggs moving through there on a daily basis.
Yeah, this plant here is a 2-shift operation. So we start production at 6 a.m. in the morning. We run till 11 o'clock. And at 11 o'clock, we have to do what's called a wash down. It's another regulatory requirement where we stop the equipment, pull all the eggs off, and we have to do what's called a wash down, change out our wash water. It's about a 30-minute process before we start back up. We do that for 5 hours, do a 30-minute wash down, do another 5 hours of production, a 30-minute wash down, and then another 5 hours of production. So essentially we're running the production line for 15 hours.
Okay. So what's that big machine we're staring at right now? What's it do?
So we'll go the other direction. We'll go back to the line. So we got the first step after the loader pulls the eggs onto the line is through a wash process.
Okay.
So there's 2 washers here, and we are regulated by USDA to have, we got temperature parameters we got to meet. We got pH parameters we got to meet. So the minimum temperature requirement that we can have is 90 degrees. Typically we run it around 100 because you have a little bit of spike in those temperatures as the cold eggs are coming through. pH, we run at about 12 pH. Our minimum standard is 11. And if we get below that, we have to shut that off. We do have quality techs that come through this process every 2 hours, check the temperatures, check the pH to make sure we're abiding by all regulations. So here you got a shot of the eggs coming out of the washer. So they just got done coming through the washer, and they're going through what's called a candling process. So what the candling process is doing is our employees are removing any ineligible eggs that can't be broke from the line. So if he pulls one like he did there, he's actually putting it in a chute right by his waist, and that chute funnels the eggs out into what we call our inedible room, where it actually goes through a screw press, squeezes as much liquid out of that shell as it can. The liquid is diverted into a chilled container, and the shell is diverted into the back of a drop trailer. The inedible egg is then shipped off to pet food manufacturing. The shell is hauled out, and it's ultimately land applied for the cow swine.
So even though the eggs are going to be broken and turned into liquid, if they come in with a crack, they are pulled out, correct?
Well, as long as the membrane is intact, we can still break that egg. Meaning, so if there's some shell imperfections in it, we can still break it. But if there's any leakage, then it has to go down the inedible channel.
Okay. And then I think, Cliff, we had another question. I think you mentioned that that eggs have to be processed within 2 days. Is that true? And why is that 2-day rule in place?
Well, they don't necessarily have to be processed in 2 days. So there's different levels of product that we put out of here. If you want longer shelf life product, you essentially want to put the freshest eggs into the system and process it through and get it in a finished container as quickly as you can. So our product that comes out of this facility, some of it has 28-day shelf life and some of it has 12-week shelf life. So there's different standards of that product shelf life, and that's determined by the shell eggs going into it.
Okay, that makes sense.
Okay, so we're gonna go on a little walk here. We gotta walk around the machine to go to the next step in the process. But as we walk, you're gonna see another piece of equipment on the other side here shortly. And that piece of equipment cleans all of our material. So all these egg flats that the eggs are sitting on, they do not go back out to the farm until everything is cleaned up and identified from where it was cleaned before it's shipped back out to the farm. Part of the reason is, one's a food safety concern. We don't want to send dirty flats out. And two is the spread of disease. So right now in the industry, we're dealing with a major issue with high path AI. We don't want to cross-contaminate any of our flocks with material. So we're pretty stringent on making sure all of our material is clean very well to a high spec.
And when you say high path AI, I just wanted to, so that's high path avian influenza for those that are not familiar. And so it's essentially a flu virus that is deadly to chickens. And it's, as Cliff said, it's all over the country at the moment. So we're really keeping an eye on things.
So we're gonna get walking through what we call our clean room, and it's right before we go into our breaking process where we see the first exposed liquid. A part of this clean room, anybody that travels in here, part of the process is washing your hands down before you walk in the room. And the reason for this is because you got the first exposed.
I think we might have lost them. Oh, there we go. I know we're kind of losing you, Cliff, a little bit. There we go. I know it's hard. There's a lot of concrete.
So I'm going to take the gimbal here. I'll still talk, but Lisa's got to wash her hands as well before we go in there.
Okay, and so, Cliff, you kind of cut out a little bit. Yeah, can you just explain like a little bit of, you know, for food safety where you wash your hands, we see you have the gowns, the hair nets, and just a little bit more all what the steps you take for food safety?
Yeah, it's all related to food safety and food microbiological contaminants getting into our open rooms where you actually see exposed products. So we want to minimize any risk on our end. So we take as many proper precautions as we can prior to going in those very important rooms to us from a food safety standpoint. So we're going to walk into the processing room here. And we'll start at the beginning of the process. So what you're seeing right here at the beginning, when we looked and I showed you the candlers, this is the next step. It comes through a wall, and this is our last line of defense for employees that are removing any ineligible eggs before they actually go into our breaking process. So it's just kind of, like I said, a last line of defense to not let any ineligible eggs go in. Once they get through this employee, they actually go into our machine, and the machine runs at a pretty high rate, so you don't get a good look at it now, but here in a couple of minutes, we're going to show you a slow motion video that kind of shows you exactly what's going on inside this machine.
How many eggs can that machine process in a minute or a certain time frame?
So the rated capacity, and Lisa can jump on it here, we're running at 360 cases per hour is what that's identifying. The machine capacity is 400 cases per hour.
How many eggs are in a case?
So cases, there's 30 dozen eggs in a case.
Okay.
And 12 dozen eggs in a dozen. So I don't know the math off the top of my head, but 400 times 30 times 12 will give you the exact egg number.
A lot of eggs.
So now you're getting it. Yeah. Now you're getting the first shot of the exposed liquid that's coming off the machine. What it does, the egg cracker breaks the egg. It drops the entire egg content into the top cup. That top cup is open on the bottom. It's got surroundings, and you can kind of see the whites that are bleeding down into the bottom cup. So now we got some separation. We got some yolk in your top cup, and we got your whites in your bottom cup. When the liquid egg travels off this machine, it travels down 3 lines. It travels down a yolk line, a whites line, and what's called a whole egg incidental line. The whole egg incidental line is essentially whites that have been contaminated with yellow or yolk. So what's happening here is above the employee's head, there's 2 cylinders. They're essentially cameras that are detecting color. They're reading the bottom cup and telling the system that if the whites have too much yellow in them, to send down the whole egg incidental channel. So now that's how we get our 3 pass between our yolk, our whites, and our whole egg incidental.
So do you have some customers that only want the egg whites and then others that want the egg yolks, correct? Is there a difference in the products that they make because of those then?
We do, and I would say from our standpoint, I would say 70% of our sales are in a whole egg form. So in many times, all the 3 channels of liquid come back together to get back to the whole egg that it started in. So the table that you're seeing right now is a whites table. So our whites line runs through this. And what she's doing is she's pulling any yolk fragments out to make it a better, more pure white. So if you guys can think about cooking an angel food cake, the whites are what's commonly used in the angel food cake. If you get too many yellow or yolk fragments in it, it prevents the rise and the expansion. So we try to get as pure a white as we can off the whites table. So they're using a ladle to just pull the yolk fragment out of the whites.
And then I don't know if you see this very often, but we did have a question from Allison Remmer in regards to double yolks. You know, is that very common, or what causes that? Do you see that? Is that an issue with your egg breaker machine then?
It's not very common. I would say probably in, you know, maybe less than 0.5% of our eggs. But it's in the bird's reproductive system that causes that. So I'm no expert on that, but I can tell you from an overall standpoint, it's fairly minimal. And typically you would see it in the older flocks or the larger jumbo type eggs. So what you're showing right now are sight glasses of the 3 product lines coming off the breaker. You can tell by the color which one the yolk is, which one the pure white is, and which one is the whole egg incidental, just by the color of the 3 lines right there. So after it travels through that sight glass, it then goes through some flow meters. So those flow meters are taking a reading every 2 minutes, which captures the data so we know how we are progressing through the day with our production process. So after it goes through the flow meters, it then travels through a what we call our chill press. The chill press has got 3 sections, which is our 3 channels of product. We got our yolk section, our white section, and our incidental whole egg section. You can see that by the way that it's spaced out, our whole egg in section is a lot less. So it covers about 10% of our total liquid that travels through there. Then we have about another 45%, that is our whites. Excuse me, 55%, not 45%. And then 35% of our egg, which is our yolk. So what happens is the product travels through here. There's chilled glycol that travels through every other plate, and there's product that travels through every other plate. That glycol, just from the surface exposure, goes from roughly 60 to 65 degrees coming off the breaker, and it takes it down to about 35 degrees roughly for each of our products off of our breaking machine. Regulatory standards show we have to have our product at 40 degrees or lower within 2 hours of the egg being broken.
And to clarify, Cliff, the glycol and the eggs never touch. It's just, it runs by like a plate or something to cool it down that glycol has chilled, correct?
That is correct. So it is food grade glycol, but they do never touch. These presses are built with pressures that disallow the glycol to leak into the egg section, but it still is food grade glycol. So, okay, so we're going to be walking out of the egg room, and we're going to be going to our tanker silo bay. We're going to have a little gap here. We've got some shady surfaces. I think we're going to show some slides here to see.
Yeah, like I mentioned earlier, it's kind of, there's a lot of concrete in this facility, so it makes it a little challenging. If Cliff, can you, and Lisa, do you still hear us? Or so at this point too, I know we had a question on, as far as we talked about avian influenza a little bit earlier, and I wanted to touch more on that as we watch this neat video of the breaking and the cups. But avian influenza, so they don't have any birds on this site, but you saw how they have hair nets and they have suits on and wash their hands. And there's lots of similar and more steps on the farm as well to make sure that we do not bring the virus with the birds. So the main way the virus is being spread around right now is by wild waterfowl. And we know that the wild waterfowl, we have testing measures in place and work closely with the Department of Natural Resources. And so we know a lot of those birds, they can have the virus and not get sick from it. So they spread it, and it can be deadly to our poultry, turkeys and chickens in our houses. So lots of steps and measures in place. Just wanted to talk on that because it is a big deal at the moment. So, okay, I see, Cliff, we're at the tanker. I'll hand it back to you.
Okay, so we just walked through our silo bay where we don't get some good service, so we had to pass through that area. But anyway, we have 6 silos that hold all of our product, and they could hold anything from yolks to whites to whole egg. We break a lot of cage-free eggs, so there could be cage-free whole egg, cage-free whites, cage-free yolks. Well, it's stored in those silos before it's sent back on to further processing. So from those silos, it can be shipped to further processing, or it can be shipped out here into our tanker bay. Now, rewind back about 5 years before the pasteurization process, all this area was used to fill our bulk trailers. Today, we're not using any bulk trailers because all of our product is getting shipped out in 20-pound bags, 30-pound bags, totes, but nothing's going in bulk containers. So, but anyways, when we did do the pasteurization project, we segregated the two bays here. So we have one bay that's designated for raw product and one bay that's designated for finished product. So we've made some modifications to disallow any mistakes from being made from a raw versus finished product out here in the tanker bay. So the next step in our process, we're going to go back into our pasteurization area. So we're going to have about a 2-minute delay while we walk back there and pick back up. We're going to show you some videos of the inside of the breakers I alluded to before, so you can see what's going on there in slow motion.
And then Cliff, as you're walking, if you still have reception, would you mind, you mentioned cage free. Could you talk on that a little bit of the differences? We did do a virtual field trip on the different housing types, but then how maybe those eggs and even then the broken products are marketed a little bit differently.
So on the cage free side, it's things are going in that direction overall. So right now, from a production standpoint, I would estimate we're roughly around that 50-50 range of breaking cage free versus commodity. And on the cage free, essentially, the birds are free to roam within the barns, whereas in the commodity system, they are in the cages the entire time, and they don't have much room to roam around. But we're selling everywhere throughout the United States, and every state there's different requirements. So your Californias, your Massachusetts, I think there's roughly 10 states now that have basically put laws into place that will only receive cage-free eggs in their state. So we're kind of adapting as the laws are changing.
Yeah, so essentially you keep those eggs, there's different marketing methods, so you keep those eggs separate then.
They're completely segregated. So if we're going to run cage-free, we will start the day with cage-free, and then we will evolve into the commodity. The other way around, it can create issues because you can't contaminate any commodity in the cage-free, but it's okay to put the cage-free into the commodity.
Okay. Can you explain a little bit more about pasteurization and how that works?
Okay, sorry. The pasteurization process, it's about a total cycle time of 4 minutes roughly, and it's depending on what product that you run. It's basically heating the egg up to kill any micro factors that could be in the egg, any salmonella, anything that could harm the egg. It's killing all those pathogens. So on average, we probably get our temperatures up to about 150 degrees, and it travels through our process for about 4 minutes before it's brought back down to the original 35 degrees that it goes in at, and ultimately packed off then. So we're getting closer here. Okay, so we're going to be going into what's called our blending room. So in our blending room, it's essentially what I'd stated, just blends ingredients into the egg. So we blend anywhere, sugar, salt, citric acid, gum are some of the common components that are blended into our egg. You got a picture of a silo here. These silos are storage containers that is receiving the egg from the breaking side. So it's shipped from the other side of the plant into these silos. And if the spec calls for blending, the blending's done, goes back into the silo, and we have quality techs that test the product to make sure that we're meeting customer spec before we start the pasteurization process. So once we meet the spec of the pasteurization process, you can see the first steps of the pasteurization. So the tank that you can see that has the danger, confined space, do not enter sign is our balance tank. And that's essentially used to make sure the flows are balanced throughout the whole process. So we don't have stops or starts because it would ruin the whole process. So once it goes through the balance tank, it goes through a heating section, which is the big chill press that you can see with 3 sections to it as well. So it would go through one of those sections, the one furthest to It's my left. I'm not sure how you guys are seeing it. And it would heat it up to about 115 degrees. And then it would cycle out of there through a pump. And then it would go through the middle section where it's heated up to the desired temperatures, which is typically around the 140, 145 degree range. After it goes through the middle section and is heated up, then it goes into the holding tubes, which we'll go see here shortly. But when it comes back out of the holding tubes after it's met the spec, which is roughly 4 minutes, then it comes back out and it's got to be re-chilled down to 35 degrees. So it goes back through the middle section, and that's the interesting part of this chill press, where like on the braking side, you have glycol on every other plate and product on every other plate. In our middle section here, you have raw product in every other plate and finished product on every other plate. And they are essentially using each other's resources to preheat and pre-cool, depending if it's going into pasteurization or coming out of pasteurization. So the product coming out of pasteurization is roughly the 145, 150 degrees. It comes out, pre-cools, back through a pump, and then back to the final cooling stage, where it also needs to be 40 degrees or below within 2 hours. Typically, it's coming out about 35 degrees. So we're going to step over in another room, and we're going to show you the, after it comes out of that chill press, the holding tubes and where the product flows through.
Cliff, I had a couple questions from Ms. Thomas in regards to shelf life of the final product and if there's any preservatives added into the egg.
So no preservatives, just some ingredients that are added into the egg. Some of it's for color stabilization. Some of it's for customer spec, you know, the salts, the sugar, going into potential ice cream manufacturing, whatever their spec calls for is pretty much what we do.
Whatever the customer asks for, basically how they tend to use it, you guys will add in what they request, correct?
That's correct.
Okay.
Yep. So now you're seeing the holding tube. So when it comes out of the press and it's heated to the spec that is called for, again, roughly about 140, it basically just flows through those holding tubes to maintain that temperature for the whatever the desired time is, roughly 4 minutes. Once it meets that spec, then it comes back out and comes right back into the chill press to be chilled back down. There's a valve and a thermometer at the very end of the holding tubes. That is our critical control point within the plant, where it is programmed that if it doesn't meet the spec, it would be diverted back to pasteurization. So it confirms you meet the regulations that were set forth by USDA.
And then Cliff and Lisa, we've got about 5 minutes left. So I just wanted to give you a heads up, but I know you mentioned like totes earlier, and can you just talk a little bit more about how some of that final product leaves your egg processing?
So we just got done with the pasteurization process, and we're walking over here to view some packing off. You can see in our cooler right now, we just got some totes, which is 2,500 pound and 2,000 pound totes. A lot of that's for your bigger customers that are your high usage bakeries. The 20-pound bags we're actually running right now, and we're going to get in there. Kind of a neat process. So we'll get in there and show you that. We're going to have to do a hand washing again here shortly, so you have to bear with us.
So some of the customers, if they're buying large amounts, they'll further process that egg product. And when you said like the large bakeries, like what kind of products would they turn that into then?
Cookies is a big one. We have some cookie customers.
Okay.
The ice cream customers again. One, if you guys go into Kroger, there's a company, it's called an egg bite. It sits right next to the shell eggs, and it's called, the brand is Three Bridges, and it's basically a cooked egg with bacon and cheese blended into it. And that's one product that our eggs are going to that customer. They're processing it into these egg bites and ultimately selling into the retail market. So that's one that I actually was in the store this week and bought for the first time, and they really are delicious.
Yeah, good. And I know, because I think this is important. We're seeing all kinds of different rooms and jobs, and I know as we're moving on to this last section, would you mind talking a little bit about like your, what are some other jobs potentially at Cooper Farms, and what does that look like? We're focusing a lot on food safety, but even in this processing plant or other areas at Cooper Farms, what other job opportunities are available?
So just on the egg side of things, which I'm most familiar with, we've got everything from quality techs. I think we have 5 or 6 quality techs in this facility. We have 7 maintenance techs to work on the equipment. We have a shipping person, warehousing, and then production employees at different levels. So on the pasteurization side where we are, it's a more higher level position than on the breaking side because it's more important. Not necessarily more demanding physically, but you need to be on top of your game to do some of this. So right here, what you see is our filling machine, and what we're filling is 20-pound bags. So if you guys have ever seen pop syrup that's sold in the stores, this is essentially the exact same process. This piece of equipment is used in the pop industry, filling these bags just as well. So it's pulling each bag out, takes roughly 8 seconds to fill the bag. It goes through a metal detector to make sure there's no shavings that could have came off the machine, and the product is wholesome and good to go out into the public.
Very neat. So where do a lot of these egg bags go? What kind of products?
They're also going into the bakeries, but
Okay.
A lot of times the plants that use these are maybe high users, but use them on different product lines. So they can't use a tote necessarily because it's a shared package between multiple product lines in their plant. So they might do bags in different areas. That's
Okay.
one thing that we've come across. So you can see that this is, besides the stacking of the boxes, this area is pretty up to date with automation. You got the box directors forming the boxes. They're conveyed right along, dropped into the box, sealed automatically, and then sent over and packed off manually.
And we have a couple minutes left. Lisa, I don't know if you're able to talk. I know it's hard holding the camera as well, but can you tell us, are you able to tell us a little bit about what your job entails? Because I know it's a little bit of a different realm altogether.
Yeah, so we're gonna step out of the boxing room here and hopefully you can hear me a little bit better. But I work on our live division side primarily. So in the beginning, I had talked about all the different animals that we raise. We actually hire family farmers who help us raise those animals. So we partner with local farmers and they are the ones who raise our animals for us up to full grown age. So I work primarily with those farmers. I'm kind of a liaison between Coopers and those farmers. I just stay in communication with them, make sure they have everything that they need. We also have service technicians, and those are specific to each species. And they are also out working with the farmers more on a technical standpoint in terms of animal health, processes, procedures, biosecurity protocols. Whereas I work with them more on a PR communication standpoint. So I might maybe work with someone like Jenna at OPA who's putting together new biosecurity protocols and programs. So I might work with her. She lets me know what those programs are, and then I can distribute those down to our internal team and also to our farmers. So we have the latest information. If there's any sort of like animal health changes, I might communicate those. And then I also do a lot of like PR community outreach work, doing virtual tours like this, going out into classrooms for different show and tells and presentations, and just getting a little bit more involved in the community, and also bringing our farmers out into the community as well to kind of talk about what they do to raise their specific species.
Well, thank you, Lisa, and thank you, Cliff, so much
Yeah.
for your time today. This has been such a neat virtual field trip that, obviously something that we don't see on a regular basis. So again, I wanted to thank our sponsors for today, OPA, Cooper Farms, thank you for hosting us, and Grow Next Gen. And anybody on, you can find more materials on upcoming events on grownextgen.org/events/Chickenology. And then we also have our previous virtual field trips, as well as this one will be posted on that website as well. So again, thank you, Cooper Farms, for hosting us. And we hope you all have a great day and happy holidays.